Basic BGP configuration. This nugget is by far one of the hardest for me to record, simply because BGP is so awesome and can go on for a long time. I just kind of get this vision in my mind of jumping on a motorcycle and riding down this highway forever and ever and ever. Just, oh, and look over there. Oh, and check this out. Oh, you gotta see this. But I find myself with handcuffs restricted by Cisco SPNGN2 certification exam boundaries. So, try as I might, what I will do is give you what you need to know and probably a little extra because it's virtually impossible to just show you like two commands that they want you to know for the SPNGN2 exam. I'm going to show you a little bit of BGP and beyond on how to bring up eBGP and iBGP sessions and exchange routes. So let's get the lay of the land. We have two ISPs, ISP 1 and 2. These guys running iOS XR, a little more modern ISP. These guys running the standard iOS, so that way we can see the configuration on both of them. We've got Autonomous Systems 6509 and Autonomous Systems 5505. So again, put this into real-world perspective. This could be you and I, sitting here at ISP number 1, running our organization, this feeding back into our core, this feeding back into our aggregation points. We've got our DSL, our cable, our fiber customers, our whatever sitting out here, and we're actually bringing them into our core, into our organization, and then saying, okay, how do we get you out to the rest of the world? Now, meanwhile, here at ISP1, we have our own little blocks of IP addresses that we can set up and we can use for our organizations, distributing to our customers, and then advertising out to the rest of the world. Happens to be connected through ISP2 for now, using BGP. This would be our eBGP relationship, advertising our routes to them, and then ISP2 and whatever else is down here. Obviously, a real ISP would have a lot more uplink connections because you don't want to put all your eggs in one basket with ISP2, but you would start receiving all of the internet routes via that BGP relationships from them. Now, see, I'm already going down the road. Hang on. I'm putting the bounds on, but I've got to answer the question, well, how far does that go? I mean, you just got, 200, 300, 400 megabyte routing table dumped on you by ISP2. Do you feed that into your entire organization via iBGP? What routers need that? Well, it really is up to you. I would say if we were to rewind 10, 20 years ago, you would say, no way, no way. We don't want to send that full BGP table into the entire service provider because we would have to buy very, very beefy devices to be able to handle that. But in modern times, as we fast forwarded, it's not uncommon to find a router that can handle a BGP routing table and can route with it. So I'm finding more and more ISPs that are actually feeding the entire internet routing table in. Others will actually filter it out. They'll say, okay, well, we'll send some routes into our aggregation routers, our core, and things like that. Well, core is a little bit different, but aggregation routers, and we'll just use a default route, for our aggregation routers to reach the edge, and then the edge is the one that has all the knowledge for the rest of the the internet. I'm sorry, a little side tangent. There's a new trainer. Well, I don't want to say new because maybe he's been here for a little while, but just I love listening to him at CBT Nuggets. His name is Garth Schulte. I've actually only spoken to him once. I'm gonna get to know him soon, but I love listening to that guy. He is like the ultimate surfer trainer, to where he's like, all right, man, we've got some databases, and we're going to make them talk, right? Right. And so I've listened to a few of his nuggets, and I find myself, like I just heard myself sound like a surfer just a moment ago. So I'm not Garth, but I'm trying to get there, man. So where was I? Okay, basic BGP configuration. So let's start off. Let's start off over here. Let's go iOS. Wow, that was dyslexia. iOS on you first and talk about BGP. So starting with the provider router 1, bring that on over into the picture. Right now, let's just get a lay of the land, show IP interface brief. We've got, looks like a couple interfaces. Notice that now this is the same topology we use for OSPF and ISIS earlier in the series. But this provider router 1 or P1 has the connection into iOS XR or our core routers over here, C1 and C2, via that fast Ethernet 1/0. Now I've given them a little loopback love, loopback 10, 172.16, 1.1, just so they have something to talk about, something to advertise to their neighbors. So First things first, I'm going to go into global configuration mode and do router BGP 6509, which is the autonomous system number. Now, a router in the BGP land can only belong to one autonomous system. Once you've done that, like if I exit back out and say, well, let's also put it in router BGP 3, it's going to say, no, you can't do this. It's not like a process ID or even a EIGRP autonomous system where you could kind of jump and do multiples on the same router. Not so in the BGP. You land in that world. So first things first, let me just hit the question mark. Show you, I mean, there's a decent amount of commands, I suppose, maybe a page worth in this window size of commands, but really just about everything that you do in BGP relates to a neighbor. Why is that? Because it's all about relationships. As you bring up these neighbor relationships, you're going to start feeding these routes, and you're going to say, well, that neighbor's not as preferred, or ooh, that neighbor is preferred, or that neighbor has these routes, and I like using, for instance, let's just go practical. Let's say I'm on C1 and I'm receiving routes from here. I'm receiving routes from here. I might say, well, 5 of the routes are really good through here, so I want to treat those routes and give them a higher weight or higher local preference. Remember the BGP attributes we talked about in a previous nugget. So you can, but it's all related to a neighbor. You're receiving the routes from a neighbor, so most of our commands, let me show you this, go back over here. I'm going to type in neighbor, followed by 10.1.11.1, right? Sorry, I'm looking at, I was just talking about core 1, but I'm looking from P1's perspective here. So 10.1.11.1 and hit the question mark. Now check this out. Bam! Page 1. Bam! That's actually not as many as I thought. Page 2, but at least more commands than there was in the BGP routing process as a whole, right? So we see a large number of commands that are all related to the neighbor. What password for authentication do you want to use for that neighbor? What kind of prefix list? That's a filter, kind of using a filter to say what networks are allowed. What is the remote autonomous system? Do you want to remove any private autonomous systems from that neighbor? I mean, it's just like private IP addresses. You can actually strip them as they come in. So I mean, just going down the way, this is all the stuff that we can do, and you can see it's almost always related to the neighbor. Matter of fact, we talked about the attributes, right? Weight. Weight being one of the strongest attributes, or the strongest attribute that BGP has. I can say right here, for that neighbor, I want to set the weight to 6,000, right? Now I'm just throwing that out there. What would happen at that case is all the routes coming from this neighbor would be assigned the weight 6,000, and now this neighbor would probably be preferred over anything else unless I set a higher weight there. Now, that is like a sledgehammer command, right? It's saying all the routes. It could be hundreds and thousands of routes, hundreds of thousands of routes coming from that neighbor that are all getting tagged with that weight. We'll typically want to combine our neighbor commands with something like a route map. I'm going down the highway, I'm telling you, but just want to give you a feel for what this is like. The route map is so core to everything BGP, and they don't talk about it in the SPNGN2 series, but I want to tell you about it because the route map is your programming language for BGP. It literally is a series of if-then statements. That's why I say programming language. You can say, essentially, you ever program in BASIC? My old Commodore Amiga, there was a BASIC, line 10, I'd say echo, hello world, and then I'd say line 20, go to 10, and you'd end up with this screen full of hello world because the program is looping, going back to line 10. Well, route maps are the same way. Why am I so excited about this? But I would say sequence 10 of the route map, if I see, routes beginning with 100, I'll just say x.x.x, coming from this neighbor, then go ahead and tag it with the weight of 6,000, right? We might do something like that. But then I'll say, but if I see routes with coming from that neighbor that is with 200, then I'm going to, you see where I'm going with this. Then I'm going to tag it with a weight, 5, really low weight, if you will, comparatively to at least sequence 10. So 30, 40, you can just keep going. You can say, well, then for everything else, just go ahead and set the local preference to 90 or set the whatever. Down the road of BGP would go, that's a route map. That's what gives you all that flexibility. Anyhow, let's go back to the base configuration. None of this matters if your neighbor isn't working. So I'm going to type in neighbor 10.1.11.1. Who is that? That's C1 from P1's perspective. First command you always type in remote autonomous system 5505, which tells this router, P1, this is going to be that wasn't supposed to happen. This is going to be an eBGP relationship. Obviously, I had done this before, and I thought I had cleared my configuration off, but we're gonna fix that right now. We won't have no unplanned neighbors in this neighborhood, so I'm gonna bring this up. Hang on, we're gonna kill username XR1 Cisco. Go in here. No router BGP 5505 commit. That's taken care of. No more of that madness. All right, so neighbor has gone down. We are no longer forming that neighbor relationship because we're not supposed to be able to yet. So, but what a great example, right? Because right there, you're like, can you spin anything to make it sound like you meant to do that? Yeah, kind of. So great example. That's really the core command to make that neighbor relationship work. Once it realizes who that neighbor is and what their remote autonomous system is, it knows how to form that neighbor relationship. Okay, what's next? Well, remember that I was talking in one of the BGP concepts nuggets earlier that most service providers now use something known as MBGP. Multi-protocol BGP, which we have this BGP train car, if you will, that forms the neighbor relationship and kind of leads the way. What is that? The engine of the BGP relationship. But attached to it are all these other protocols. Now, what are those? They could be IPv4 routes. They could be IPv6 routes. They could be IPVPN routes, meaning stuff that your customers are using over maybe a metro Ethernet circuit, and you're kind of carrying it using BGP, but you don't want to adopt it into your routing table. So these are all known. These little extension cards are known as address families. Just think of them like cars, with little families in there. Yeah, we got the IPv4 family sitting over here eating some chicken. IPv6 is asleep in the sleeping car. So all these address families can be carried by that BGP engine. Now, keep in mind that the iOS has gone through many iterations, and MBGP wasn't always around. So the iOS supports normal BGP out of the box, and by itself carries IPv4. So if I were to draw it as a picture, we'd have our same little train car, obviously a little older because it's kind of jacked up. But this guy over here is IPv4 and BGP. Like, this multi-protocol business didn't always exist, so these little extension cars weren't always going. So you could do this with the iOS just by coming into that configuration mode and saying, well, I'm going to go in and now start adding my networks and defining what's going to be advertised. And it would work, using quote-unquote normal non-multi-protocol BGP. However, what I would suggest is go the address family route. Start setting up the little train cars, because that's, number one, how iOS XR handles it. It does pretty much like a MBGP only kind of configuration, because that's kind of the mindset that it has. But also it keeps it consistent on all your routers and gets you in that frame of thought. So here's how we do it. I'm under router BGP. I'm going to type in address family, hit the question mark. You can see this is currently, it's like, what kind of train car do you want to add to that caboose? There they are, NSAP if you want to run the OSI protocol. But we're going to do IPv4, and then you even have different models of train car from there. Unicast. I'm going to say this is normal unicast routing, not multicast, nothing special here. Not a VRF, virtual router forwarding instance that can take customer routes and separate them from somebody else. But we're just normal. This is normal routing. Notice the mode that we go into is router address family. And I'm going to start typing in. Let me just do a show IP interface brief. I see my interfaces, but let me also do a show IP route. Do show IP route. Because I want to emphasize something that, there's nothing special there. I want to emphasize something that occurs, right? So think of BGP. You might remember in one of the previous nuggets, I described BGP as like a layered cake, right? You have hang on, let me go red on you. You have kind of the lower layer, which is an IGP that runs inside of this. This is like your OSPFs. This is your ISIS. Essentially making the internal routing work. And then on top of it, that's where you bust out your BGP. And that's BGP just kind of rides on top of whatever internal structure you have here. And the internal structure is not really seen by anybody via BGP. It's like the road. When you're driving a car, you're not looking down at the road. You're looking at where you're going. And BGP is the same way. It's kind of sending these external routes from the internet internet over on top of this layered cake that we call IGP. That's the foundation. So you might see inside of your routing table here routes from OSPF if we were actually running that, or ISIS, or EIGRP, or RIP, or static, or blah, where does they're just routes in your routing table. And BGP allows you to take the routes from your routing table and put them into that BGP process. So you can take internal routes, which maybe they're internal, maybe they're private, maybe they're not. Remember, BGP can be used for all kinds of stuff, not just public routing of internet routes. You could take anything that is in your routing table and you can put it into the BGP table. That's the job of the network command. So, hang on, let me clear off some of the gibberish that's going on here. The network command is totally different in BGP than it is in normal routing protocols. Normal routing protocols like these guys, when you type in network, we'll just say 172.16.1.0, right? What's it do? Two things. One, advertise that network, right? So it's going to start telling everybody, hey, I know about this network. But number two, start sending hello messages on that network. Well, BGP, number one, doesn't do the hello thing. It doesn't discover neighbors. We just saw, based on the configuration I showed you, neighbors are manually configured. I go in and type in neighbor such and such, and that's what forms the neighbor relationship. They do not discover themselves. And the network command, what it does is actually look at what's in the routing table. Maybe it's from OSPF. Maybe it's static. Maybe it's a loopback interface like we're going to have in this case. It just happens to be in the routing table, and it's going to advertise. It's going to move it from this internal table into the BGP table and then advertise it to all of its peers. Does that make sense? Hopefully. Okay, so here's the next command we're going to do. And trust me, the rest of this will go faster. I'm just kind of expounding on some of the key things. I'm going to type in network 172.16.1.0. That's the network that we're advertising. Now you and I know that it is sitting there on loopback 10, right? It's got this individual route. It's not really a network, but BGP doesn't know that. Now I want to show you something really, really critical. Notice we can either hit the enter key or type in a network mask. So, in order for me and you to move a BGP table or to move a route into the BGP table using the network command, we must type it in exactly as it is in the routing table. If I were to hit the enter key right now, BGP would assume that this 172.16.1.0 route actually has a /16 mask. Why do you think it does that? That's the default. In the classful world that we came from when the internet was invented, the 172 network has a class B address out of the box. Now, am I doing that in my environment? No, I am not. It's a /24. I've subnetted that route. It's lazy subnetting, but it's subnetting from its original /16. So I must type in mask 255.255.255.0. Otherwise, it's not going to add it. And okay, I'm so glad I just thought of this. This is one of the big difference. Remember in the internal routing world, like with EIGRP or OSPF or RIP or any other routing protocol except BGP, we can type in like network 172.16.0.0, right? And what's it do? It looks around at all of its interfaces and says, hey, any of you interfaces, do you start with 172.16? Because if you do, I'm going to send advertisements. I'm going to send hello messages about those interfaces. Anyway, okay, you, and it starts adding the interfaces, right? Not at all how BGP works. BGP, think of this as like a sniper, right? I'm identifying a single network in my routing table. This guy. 172.16.1.0, and I'm saying I want to move that from my internal routing table into the BGP table and send that to my external peers. So you might say, well, what if you had 100 you had 172.16.1 and 2 and 3 and 4 and 5 and all these hundreds of different routes in your routing table? Do you have to add them one by one? Yes. Didn't expect me to say that, did you? Yes. Yeah, if you're going to use the network command, you do. You actually have to type it in. There is no sweeping way of doing it. Now, hang on. You can summarize. You can do. There's tricks, and then you can also do things like redistribution. I can redistribute from my internal routing table with filters because I don't just want to send everything into BGP. That's it's beyond the network command. So just think of the network command. I can't emphasize that enough because it was so confusing to me when I got into BGP many moons ago, because I was so used to how these protocols work that I was like, oh, well, I'll just it doesn't work. You can't just type in a broad mask and sweep a whole bunch of networks in just like that. Okay. Now, one more command here. Neighbor, no, not network. Neighbor 10.1.11.1 activate. What is that? Well, this up here, up here, right there, forms the neighbor relationship. It says, hi, my name is provider 1. I'm at 10.1.11.2. I'd like to introduce myself to you. I'd like to form a neighbor relationship. Okay, we are running BGP. We have a train car, or I should say a train engine that is running BGP. Now, what I just did is I went in there and I said, oh, and by the way, I'm going to add a little train car extension, and it's going to carry some IPv4 routes, including this 172.16.1.0, and I'm going to go ahead and activate this for that neighbor. So instead of just forming the base BGP relationship, I'm also going to include this train car when I'm speaking to that neighbor. Does that make sense? Good. Okay. So that's it. I'm gonna go back now. Right now, I destroyed the neighbor relationship already. So I'm going to type in a few key commands. Show IP BGP summary. Love that command because it is the flyby view of the neighbor relationships. Check this out. If I type in show IP BGP neighbor, it's like bleh. It's like a show interface. Let me just throw up on the screen all kinds of different information. You got to weed through to figure out what's going. Now that command can be useful, but this command is way more useful in my opinion because it's just straight up what I'm looking for. I got this neighbor, right? It's running BGP version 4, remote autonomous system 5505. We're not talking right now. Matter of fact, we are idle. There's nothing going on with this neighbor relationships. I've tried. I'm still trying to form this neighbor relationship, but they're not talking back. So this is not an active relationship as of right now. So let's head over to iOS XR and configure the other side. Oh, hang on. Before we do that, I just looked at my notes. I've got one more command. Show IP BGP enter. This shows you the BGP topology table. Kind of the behind the scenes, not the routing table. This is the topology table. This is the BGP table where it holds all of its stuff, where it's trying to figure out what it should put in the routing table. So this thing's going to get big, really big when you get connected to the internet, because you're going to have all of the best routes that you get from the ISPs, all of the second, third best, fourth best. It's all going to be right here sitting in this giant table. And as of right now, there's a whole lot going on. One route, right, that we've seen now. Can I draw your eyes? I already want when you've seen things like you talk about people that are cashiers and spotting counterfeit money. It just as people see money all the time, they just get used to what real money looks like. My wife used to work at a bank, and she said they train you. They actually, in part of your training, they hand you all these dollar bills and check this out, and they just have you feel it and look at it, feel it and look at it, feel it, look at it. So that way, when somebody busts out some counterfeit stuff at the counter, in live banking, you immediately just feel. You may not be able to look at it and say, "Oh, I can tell why that's counterfeit," but you just feel it, right? There's just a feeling you get of what's right and what's wrong, and that's how you can identify counterfeit money. I want to give you that feeling already with this table. Right here, I want you to spot those symbols: star and the little right caret. Star means this is a valid route. Meaning I've got this route. It looks good to me. Matter of fact, this would be going in the routing table if this is the best route. Matter, you know what? I have now picked it as the best. Right? This little right caret. That's the feel. That's your dollar bill feel. As you're seeing these tables, they're going to get bigger and bigger and bigger. And you start doing show commands, and you'll see a whole bunch of them that either don't have the star, don't have the caret, or maybe it has a star but it doesn't have a caret. That's what it's called, right? A caret. The thing, the asteroid shooter. So that's the feel. Just get that feel right now. This is a good route, meaning I know how to get there. I can reach the next hop. It's valid. And you know what? It's now made it into the routing table. That's what the right angle bracket means, is I've picked this one to go into my routing table. Now, I'll do a show IP route, and you'll notice there's no BGP routes here. Why? Because this guy is beating it out. Like if this directly connected interface, which has an administrative distance of 0, wasn't there, then I would see this BGP route there. Well, actually, I wouldn't see anything because that's where this BGP route's coming from. You get the point, right? So let's go to right here. This is our iOS XR router over there on the left-hand side. So I'm going to bring up this configuration. Failed to get the user ID. I don't know what that is. All right, so I'm going to log into the iOS XR. Let's do a show IP interface brief. I added a little loopback love over here too, 172.16.10.0. The other one was 1.0. Just as a network that we can advertise around, see what's going on. Global config mode. Router BGP 5505. It's autonomous system number. Now this one right up front, I'm going to say address family IPv4 unicast. Enter. The reason that I'm putting that in there is I'm starting off with that extension car, if you will. I'm saying iOS XR, you need those extension cars because that's how you do your BGP configuration. So I'm going to go in there and just do network 172.16.10.0. Check this out. /24. No longer doing the decimal subnet mask. Matter of fact, doesn't even let you use a decimal subnet mask in there. So what I've done is I've started. Now it's not order specific. I could have done that otherwise, but I started off where what I did last on the other one, configuring this extension car. So I've gone in there and said this route will be added, right? Okay. So now I'm going to go and configure my neighbor. I'm going to do neighbor 10.1.11.2, who is that P1, enter. Okay, that's different, right? Previously, we hit the question mark there, and we saw all the options for that neighbor. iOS XR puts it in sub-configuration modes. It's very much more of a modular feel. So all of those neighbor commands still exist. They're just as sub-mode commands. I'm like in the mode for the neighbor, right? So now my remote AS command, which is required, goes in right here, 6509, enter. Now I'm going to say for that neighbor, I'm going to add the address family. IPv4 unicast. Okay, whoa. Hold the phone. What? I thought we did the address family up here. Address family IPv4 unicast. And we said here's the network that I'm going to do, right? Why are we doing it twice? Well, there's one. Think of it like I need a new train. There we go. That's what I'm talking about. So in iOS XR, the BGP train engine works a little different, right? We go in, we turn on BGP, and we say, okay, the engine is running. Now, just about everything that we do relates to these IPv4, IPv6, these extensions, these multi-protocol extensions where we're saying, I've got this train car. So the very first one that we did, let me bring that back up here. The very first one that we did right here said, okay, I'm going to have this train car called the IPv4 unicast train car, and inside of that train car is going to be the 172.16.10.0/24 route, right? So I've defined the train car. Then I go down here and I say, okay, well let's define the neighbor, right? I go in to the neighbor configuration mode. I say this is remote autonomous system. Then I'm going to say, and for this neighbor, right? So I'm going to take this train car and advertise it to this neighbor 10.1.11.2, they are going to get this address family IPv4 unicast train car, right? That's all it's there for. Now, actually, there is a big difference on iOS XR. Let me back out here. Let me first off commit that. Let's just see if we get anything coming up right there. Show so many sub-configuration modes. Okay. Oh, okay. Yeah, perfect. Look at this. It says routing BGP NBR policy. No policy. No inbound unicast policy is configured for eBGP neighbor. Blah, 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 blah. No IPv4 unicast prefixes will be accepted from this neighbor until inbound policy is configured. What does that mean? So iOS XR, Cisco intends that this is not something you're running in your house. Matter of fact, it's not even something most businesses are running. This is a carrier-grade operating system dealing with customers. And Cisco says, why would you ever form a neighbor relationship with a customer without some kind of filter saying, here's what they can send, here's the attributes of those routes that they are sending. So Cisco came up with this thing called the route policy. By default, there is none. And what does that mean? Think of it like a firewall. If you configure a Cisco ASA firewall and you don't put any allow rules in there, what's the default rule? Deny. It's a firewall. That's what they do. They block everything until you say, here's what's allowed. The route policy is exactly the same way. And iOS doesn't have it. I mean, they have the capability. It's called a route map over there. But in the iOS XR world, they implement route maps through this thing called a route policy. For this SPNGN2 boundary nugget that I'm forced to abide in, I'm going to just show you the basics, essentially what we need to get this thing running. I'm going to go into global configuration mode on iOS XR. I'm going to type in route-policy, and you can say, what do you want the name to be? I'll call it pass. It is case sensitive, so I'll use all capitals. I'm now sitting in route policy configuration mode. It's like, well, what do you want to do? And I'm going to say, this is where you would apply all your rules, what you want done from that customer, what attributes you want to set. You can see the set command right there to do that. I'm just going to say, you know what? Pass. Enter. That's it. That's the most basic of basic policies that you can have, which just says, you know what? I'm going to allow. But I haven't applied that policy to anything yet until I go into my neighbor. I'm going to do router BGP 5505. We'll do the, neighbor 10.1.11.2. That's the neighbor that we're looking for. And I'm going to go back under that address family IPv4 unicast, right? And now that I'm under here, I'm going to apply the route policy pass, and then you can see what direction, inbound and outbound. What that does is give a carte blanche. Let's go ahead and commit that. A carte blanche. No! Hang on. Do show configuration failed. That didn't work out. Hang on. Commit. Let me just do a. There's nothing there. Yes. Show configuration failed. Oh, okay. Could not find entry in list policy pass. Oh, I typed it lowercase. I even said it was case sensitive. Hang on. We'll just do this. Go shoop. Get right back in that mode. Route dash policy pass in pass out. Pass out. There we go. There we go. Now we've got it. So that applies the route policy to that iOS XR router. Now that neighbor relationship is formed, it's just going to go through that BGP route selection process. So the iOS XR router, we've got that C1 linked over here to P1, right? The two different ISPs. They're now exchanging routes, so routes are going like this. They are first going into the BGP table. The one that we saw by doing on iOS XR, I haven't showed you yet, is show BGP. On iOS, it's show IP BGP. Although I've seen in some iOS versions, they make this IP optional. I think they're just trying to bring it into conformity with the other one. So the routes are received from the neighbors. They're added to that BGP table, which is where they're evaluated. First thing it's going to do is say routes with an inaccessible next hop are going to be ignored. And I'll show you how that can happen in just a moment. Then take a look at this. It goes through that route attribute list. It says, okay, higher weights, higher local preference, shorter AS path, and down and down and down that list we go. That list is what we talked about in one of the previous nuggets in this series on the BGP attributes and how it finds the best one. So let me bring that core router back into the scene. We've got that iOS XR C1. I'll just do the show IPv. Oh, see, I'm so used to IP BGP summary to verify the neighbor relationship. This is good. So we see the neighbor showing up, and this is what you want to see. You don't want to see idle. You don't want to see even active. Active means it's trying to form the neighbor relationship. You just want to see a number, which represents how many prefixes have been received from that neighbor. So from the C1 router perspective, it's formed one neighbor. It's received one prefix. Let's see what it looks like. So we'll do a show BGP. shows the BGP table. Now take a look. We've got the one network that we are advertising, 172.16.10.0. That's our loopback interface because we are the next hop. And you can see it also assigns it a very high weight, 32.768, just to make sure that it is the preferred one. No one else is going to overrule that route because I own it. And then right above it is the one that we received from the neighbor. Now, there's a lot to see here. Take a look. First off, you see the star, and you see the little right caret, which says it is a valid and its best route, which means I know how to get to that next hop, and I've added it to my routing table. So I can do a show route IPv4, and I see there's my BGP route in the routing table. Great. Let's look back up here. Notice we have an AS path now. So I is where it came from. That's its origin, one of the required BGP attributes. So it started I internally, and then it left Autonomous System 6509. Now, if we were to continue that and pass that on, it would tack its autonomous system, 5505, to the front of that, and this path would continue to get longer and longer and longer, right? So good. We can see that we are at least initially working on this. Now let's build this iBGP relationship between C1 and C2. Go into global config mode, router BGP 5505. This time I'm going to do neighbor 10.1.12.2, which you can see that's our WAN link right there. iBGP neighbor forming. I'll do the remote AS 5505. Now, that is how BGP realizes that this is an iBGP neighbor, as it compares the remote AS to its own autonomous system. And we want to make sure that we are going to advertise the address family IPv4 unicast. You don't even have to put anything under that. We're just saying this train car, where's my pen? Right here. This train car is going to be included in my advertisements to that neighbor, the IPv4 unicast train car routing table. Let's go in here and do the route policy, pass in and pass out, just to do the full access to and from that neighbor as well. Okay, so we are good. We'll commit those. Now that neighbor relationship is not going to come online until we go and configure the Core 2 router. Core 2 router in the picture now. I'm going to do a quick show IP interface brief. We do have a loopback here as well that we can advertise in just to watch it all flow. Let's go into global config mode, router BGP autonomous system 5505. We'll do the address family, IPv4 unicast. So this is going to be, there is a train car, and I'm going to include in that train car the network 172.16.20.0, mask 255.255.255.0, which is the, I mix up my iOS and iOS XR syntax all the time. There's the custom masks, which will include this. So I'm putting it in the train car. Now, I don't have to go and include all the other ones that exist out there, 172.16.10.0, 1.0, otherwise, what's the point of a routing protocol, right? The other routers will send that train car to me, and I'll just add my network to it. So we'll exit out of that, and we'll configure our neighbor. I'll do neighbor 10.1.12.1 remote AS 5505, right? Because that's going to be core 1 to core 2. So 12.1 is this guy right there. Following? We'll do let's see, address family, right? We've got to allow the address family to that neighbor IPv4 unicast. And actually, didn't do the route policy. Let's do a route policy. We'll go pass on this one, and we'll just say pass, allowing everything. Router BGP 5505. I'll just start copy and paste. Don't you always think copy and paste will be faster, and then it ends up taking more time in the end. Just remote AS, and then, I don't even know why I did that one. There we go. Unicast. Okay, now route policy, pass, inbound, outbound, just to allow all the routes going to there. Let's go ahead and commit that guy. So we'll get BGP up and running, see if it forms that neighbor relationship. And meanwhile, let me exit out, and we'll configure the external neighbor here. So this, hey, there we got our neighbor. So this one's going to connect over there to P2. So I'll do neighbor 10.1.22.2. That's going to be the external neighbor. Remote AS. What is that? 6509. 6509. Anyone pick up that I used key Cisco routing switching models as my autonomous system? Address family, IPv4 unicast, and then we'll add our route policy. Route policy, pass in and pass out, allowing all those routes, and let's commit. I don't believe I have P2 configured yet, but at least this side is. Let's do a show IP BGP summary. Dope! This guy's idle right now. So that means we have yet to... Oh, well, that's because he's not configured. That's the P2 router. This one is good, the 12.1. That's going to be the iOS XR within. That's our iBGP neighbor. We've received 2 prefixes. Let's check it out. It'll do a show IP BGP. And... Good. Oh, okay. Okay, good. Good, good. This is so good. Hang on. Look at this. We've got 172.16.20.0, right? That's R1. That's what we originated. So I would expect, matter of fact, let's just verify, that I can go over to router 1, do a show IP BGP over here, and I would see that one showing up right there. It's an internal route. I could do a show. Notice the little I right there. It's saying, hey, I got that from iBGP. That's my little iBGP. So show IP, show route IPv4 in the iOS XR world, and it is showing up there in the BGP table. Now, what I want to show you is look at this. Look at, so there's the 10 route. We see that. Right here, 172.16.1.0. Who is that? Who is that? That is the route being advertised by P1. What's missing? What's our counterfeit currency going on here? What's missing from that guy? The little caret. Little caret. Why is that missing? It says it's a valid route, right? Star valid, that's good, but it's not the best route. It's not ending up in our routing table. Show IP route. Let's just verify that. No, it's not. 172.16.1.0, even though it's in the BGP table, is not showing up in our routing. What's the deal? Well, iBGP has a rule, and it says never, ever, ever, never, never change any BGP attribute. Any of them. That's the rule. One of the BGP attributes is the weight, another local preference, another metric, another autonomous system path, and another, even though we don't think of it as one, is the next hop address. Hang on, wait a sec. What's wrong with this picture? 172.16.1.0, the next hop address, 10.1.11.2. No, whoa. Wait a sec. From C2's perspective, where's my pen here? From C2's perspective, it should be 10.1.12.1, right? It should be the next, but no, it's not. It's 11.2, which is that guy. Well, wait a sec. Let's just verify something. Can I get there? 10.1.11.2. Unreachable. Denied, which is why this isn't making it into the routing table. Remember, going back to my little how BGP picks the best routes, first thing it does is routes with an inaccessible next hop will be ignored. I guess you could say ignored. They're just not making it into the routing table. So what do we have to do? Well, there's a couple ways. One, you could tweak the policy. You could actually go into C1 and you could say, when I send routes to this neighbor, I'm going to use what's called the next hop self command, which overrules what Cisco and the RFC standards say you should do, which says never change any BGP attributes over iBGP sessions. But this overrules that. So I'm going to break the rules. Cisco does not recommend doing that. Instead, what you could do is advertise this network into the BGP process so that this guy would know how to get there, and then it would know how to get there to that next hop. Let me show you. Go over here to core 1. Let's do a show IP interface brief. Global config mode. I'm going to go into router BGP 5505, and we will do, let's see, well, I got to know what subnet mask that is. Let's do a show config, running config, interface, GI 0/1/0/2, right? Is that the interface I'm looking for? Yeah, 12. Yeah, so there. So it's a slash. It is a /30 mask. I know I've got it on there as a /30, but sometimes what I do doesn't match what I write. So I'm going to be under BGP. Let's go under the address family. IPv4 unicast. I'm going into the train car, and I'm going to say I'm going to add the network to it, 10.1.12.0 with a /30 subnet mask, right? So now when I do, oh yes, let's commit that. Now when I go back and do a show IP BGP, it may not be there yet because BGP is slow. Oh, it's there. Good. BGP, it's now advertising that. So now I come down here, hit the up arrow. Well, hang on. Show IP BGP, maybe it's just not getting there yet. It's not getting there yet. It will. So when this network shows up down here, 10.1.12.0, then, oh, wait a sec. Did I do that wrong? I did that wrong. It's a 11.0. Well, actually, that was just completely wrong. Hang on. Router BGP 5505. It's not 12.0, and that would explain why it's 11.0. So let's go address family, IPv4 unicast, no network, 10.1.11. or 12.0/30, right? And we'll just do the network 11.0/30 and commit that guy. There we go. That's a wee bit better because we actually have that network. Let's do a show IP BGP on the Core 1 router. There we go. It's shown up there. And let's do show IP BGP down here. Now I've got this. Hang on. Let's go destroy it all. Clear BGP star. By the way, you never want to do that in production. Just a tip. In reality, in the real world, if you do that in production, it will tear down your BGP neighbor relationships, which at an ISP level could be many of them containing hundreds of thousands of routes. It could be 10, 20, 30 minutes before you actually rebuild from an event like that. However, in our little lab, you can see that we're doing okay. So show IP BGP. Let's see it there. There we go. So we've got 10.1.11.0 with the next hop of 12.1. Looking good there. So, yeah, you see it? It just took it a sec. You see how slow BGP is. I'm saying, so why is it showing this? It just hadn't gotten there yet. So what it was saying is, I still don't know how to get to that 11.2, even though it had it right there. Just hadn't thought about it long enough. So when I did the command again, it goes, oh, okay. Well, now that I can get there, this one's considered valid. I now will add that. Let's do a show IP route to my routing table. Bing. But notice the next hop. This is called recursive routing, by the way. In order to get to this 172.1.0, it's going to have to look up, well, how do I get to the 10.1.11 network? And it's going to look up here and go, oh, well, to get to the 10.1.11 network, I have to go to this guy. And so it kind of does this little recursion to find its way. But, yeah, so as we drive down that BGP road on our motorcycle, yet another cactus goes by. I'm in Arizona. Cactuses go by all the time. So that's just something to be aware of. Okay, we've got to finish this scenario, right? Let's go over to the P2 router, which is our last one of the bunch. Hang on, bringing up that connection here. And by now, this is all old hat, right? We come in here. We're on the iOS router now. So global config, router BGP. Let's just get all this stuff out of here. 6509. 6509. We will do, let's see, we've got loopback address, show IP interface brief. Did I put the loopback on here? I didn't. Hang on. Interface loopback 10. Let's do IP address 172.16.2.1, 255.255.255.0. So we've got a little fake network we can play with. Router BGP, let's just hit the up arrow, 6509. And we will do the neighbor, 10.1.22.1, which is going to be our Core 2 router over here. This one we tack all on the same line, remote AS 5505, right? So we've got our neighbor configured. We then do the address family IPv4. We're going to go into that bucket, into that train car, and we'll advertise our network. We'll do network 172.16.2.0, mask 255.255.255.0. We saw our neighbor come up in the background. And then we'll also activate that same neighbor 10.1.22.1 activate for this train car. Again, iOS not necessary to do this because the IPv4 train car is the quote-unquote default of BGP, but it's good to get in the habit because this is really what distinguishes that multi-protocol BGP from just straight IPv4 only BGP, the old version, if you will. Good. I think that's it. Very basic end router. So I'll do a show IP BGP. And I see that we are receiving all of those routes that have been added to the system. I think to have a complete scenario, we would want C2 to have that 10.1.22 route added into the group. Otherwise, we're going to have the same problem with C1 not being able to see this 172.16.2. But you got the idea of that, right? The concept of it. And let's do a show IP BGP summary. And we can verify that, sure enough, we have 3 prefixes received, and the neighbor is online. Hopefully by seeing that configuration again and again and again on 4 different routers, iOS and iOS XR, you really got the feel for how that is. Again, my hope in this limited SPNGN2 world is just to give you the feel, like, oh, okay, I got it. I got that feel. Because then, I mean, everything else from here, now that you've got that base down, you're just adding stuff to it. I mean, it's kind of like, oh, you can do this too. Ooh, that's neat. Ooh, oh, look at that. Oh, and you get that, right? Good. Well, we have seen BGP, iBGP, iOS, iOS XR, network advertisements, all of that goodness in one place. I hope this has been informative for you, and I'd like to thank you for viewing.